Part B, figure 2 shows the gas syringe during one of the experiments. What is the volume of gas collected? We've got to tick one box, it's worth 1 mark. Okay, so we're looking here at, so we know that's going to be, there's 5 there, it's 10 there, so we're trying to work out whereabouts we've crossed there. So we need to work out how big each one of these steps are. So there's 1, 2, 3, 4, 5 steps there. Start at 5, so each step is going to be 1 big. So 5, so it's going to be 6 something. So it's not that, it's not that. And where is it? Well, 6 is there. It's definitely not 6. It's 7. It's somewhere in between 6 and 7, so it's going to be 6.5. Part C, figure 3 shows the student's results for 1 concentration of hydrochloric acid. And we've got a graph there. The table below shows the student's results when the concentration was 2 times greater than the results on figure 3. What have we got to do? We've got to plot the results and draw a line of best fit. Okay, so plot the results in the table above. In figure 3, it's worth 3 marks. So what have we got? Well, so the first plot we've got is 0, 0. So I'm going to make sure I'm going to use crosses. Next one is 10. It goes from here, and that's 35. So 10, 35. I'm going to run out of space here. So 10 there, 35 up. So I've got 30s there, and we've got 1, 2, 3, 4, 5. So the temptation here is that students just count 5 up, but each one square is worth 2 now. 35's there, which 35 is going to be halfway in between those two, so it's going to be here. As long as you're within half a square, you're absolutely fine. Okay, the next one is 15 seconds, which is here, and it's 52. So 1, 2, 3, 4, 5 is there. 52 is going to be there, so 50's that one. So 52 will be here. So what I might do here is just tick these off as I go, just so I know which ones I've done. 20 and 80, so 20's there. 80 is quite a straightforward one. Up to the top. And 30, 87. So 30 seconds is here. 80, 87, well that's 90. So it's 2, 4, 6, 8, so it's going to be there. 87 is there. And 30, that's going to be there. Okay, so they're my points. Alright, there'll be 2 marks available for the plots in total. Now into my line of best fit. I'm looking here going, okay, well the first line was a straight line. This one looks, if I do dot to dot, I'm going to lose a mark there. We never do dot to dots. What does it look like? Does it look like a curve, or does it look like a straight line? It looks, I mean this one's a straight line, so I would go, so we've got that as a straight line. The temptation here is to say, well, this is also going to be a straight line then. Okay, so I'm looking to have about equal points. If I can see a ruler, having a transparent ruler is slightly easier for this. Actually, I don't have one handy. I'm looking to have about equal points above and below. The only point I know for certain is 0. I know that at 0 it's got to go through the origin. So I'm going to have, none of them are sort of way out, so let me just put that there. Okay, so we've got a reaction kind of like that. Doesn't have to hit any points at all, but I've got roughly, the points are sort of close to the line. I've got this one is to the left, that one's to the right, these two are virtually on it. It goes through 0, 0, so that would be absolutely fine for a straight line. Dot to dot is not right. Remember, when we're doing lines best fit, we also never ever horsetail, that weird kind of shading thing that people do. Okay, and we squint at the line and we decide if it's straight or curved. If it looks close to straight, then we do straight. If they give us another graph with a straight line on it like this, chances are this one will also be straight. Okay, so let's have a look at next question. So, part D. Give 1 conclusion about how the rate of reaction changed when the concentration of hydrochloric acid was changed. It's worth 1 mark. So the rate of reaction was, let's see, was low here. Sorry, low concentration, and this was high concentration. Okay, so what do we notice? Well, the rate, whenever we say rate, whenever we're looking at a graph, rate equals the steepness, which also equals the gradient. Okay, they're all just the same word, or different words for the same term. So the rate is the steepness, so this one's a higher rate here. So give one conclusion. So rate of reaction changed when concentration of acid was changed as concentration of acid increased. Okay, we're always going to try and use, in fact I probably should have said concentration of hydrochloric acid. Let me just add that. I'm always going to try and use the same words they use in the question. So as concentration of hydrochloric acid increased, the rate of reaction increased. Okay, the steepness increased. That's what we're saying there. Okay, hope that helps.